Welcome to aminacademy.com. In physics, let us discuss about Carnot engine. Carnot engine is a reversible engine that operates between two temperatures T1, that is source, and T2 is sink. It gives an estimate of a maximum possible efficiency that a heat engine can have in successful heat conversion between the two temperatures. Carnot engine can be found in refrigerators and air conditioners. Carnot equation can be used in understanding the working process of heat and internal energy change in adiabatic as well as isothermal process. Here Carnot engine works in a Carnot cycle. Look at your NPV diagram. A to B is isothermal expansion, B to C adiabatic expansion, C to D isothermal compression, D to A adiabatic compression. A Carnot cycle was first developed in the year 1824 by a French physicist named Sadi Carnot. It is an ideal cycle that basically laid the foundation for the second law of thermodynamics. Carnot cycle also brought up the concept of reversibility. Here, the source, heating source is here and sink is here. That heat from heat source converted as work and go to the temperature sink T2. Therefore, the two temperature is source temperature and sink temperature is the important things in a Carnot cycle. From the second law of thermodynamics, two important results are derived where conclusions are taken together to constitute Carnot theorem. It may be stated in the form of, first one, no engine can be more efficient than a perfectly reversible engine working between two temperatures, that is Carnot efficiency. From here we can say Carnot efficiency is the highest efficiency. The efficiency of all reversible engines working between the same two temperatures is the same whatever the working substances. Now the ultimate in fuel efficiency for a heat engine, all standard heat engines like steam, gasoline, diesel work by supplying heat to a gas. The gas then expands in a cylinder and pushes a piston to do its work. So it's easy to see how turn heat into work, but that is a one shot deal. We need it to keep repeating to have a useful engine. The heat and or the gas must therefore be dumped out of the cylinder before the next cycle begins. Otherwise, all the work the gas delivered on expanding will be used by compressing it back. How efficient such an engine can be, what's the most work we can possibly get for a given amount of fuel in cyclical process. That means efficiency of the engine depends on how the work is delivered from that engine, that is maximum. We will examine here the model stripped to its essentials. An ideal gas is enclosed in a cylinder with external thermal connection to supply and take away the heat, and a frictionless piston for the gas to perform and, if necessary, absorb mechanical work. The simplest heat engine is called a Carnot engine, for which one complete heating, cooling or expanding contracting cycle back to the original was gas volume and temperature is a Carnot cycle. Carnot results was if the maximum hot temperature reached by the gas TH and coldest temperature in the cycle is TC. Between these temperatures, Carnot cycle works. Now we'll do an example problem to understand Carnot cycle. A Carnot engine efficiency is 40% and a temperature to sink is 300 degree Kelvin. To increase up to 60%, calculate the change in temperature of the source. Here 40%, that is 40 by 100, 40 by 100, that is 40%. T1 by T1 minus T2 over T1, which is equal 0.4 equal T1 minus 300 over T2. Then by cross multiplying, and 0.4 T2 equal 0.4 T1. 0.4 T1 equal T1 minus 300, which gives 0.6 T1, simplifying, is equal 300. Therefore, T1 equal 300 over 0.6 equal 500. 500 degree Kelvin. Now, next, the efficiency is 60%. Calculate the change in temperature of the source. Now, we have to calculate that calculate the source temperature when efficiency is increased to 60%. Now, new things, that is 0.6 is, which is equal, same, T1 minus 300 over T1, that is 0.61 equal T1 minus 300, which gives 0.4 T1 equal to 300. Therefore, T1 equal to 300 over 0.4, which gives 750. Now, new temperature, source temperature is 750 degree Kelvin. Therefore, change in temperature is 750 minus 500 equal to 200 degree Kelvin. We have done. Please subscribe our YouTube channel. This is a 250. Right, we'll write clear here.